Okay, ladies and gentlemen, we're here with angle proofs coming with a live action. So we've done algebraic proofs, just kind of an introduction to two-column proofs. Then we did segment proofs, so we took two-column proofs and started to do some geometry stuff. Now this is when we get to the nice meat of it all, the angle proofs. Much more meaningful. We're actually going to prove some theorems, and we're going to talk about some really intense stuff. All right. So reflexive property, for any angle A is congruent to angle A, right? This is just saying an angle is congruent to itself. We'll use this a lot in Unit 4. And then symmetric, just good to think about things. Well, if angle A is congruent to angle B, that must mean angle B is congruent to angle A. And you might say, why do I need to know this? Well, back in the day, this was mind-blowing. This was better than sliced bread. Symmetric, swap the order. Reflexive, repeat. You guys got to remember it. Students like to forget this all the time, although it's incredibly simple. Transitive, so angle A is congruent to angle B is congruent to angle A, then angle A is congruent to angle C. All right. Since they're congruent to the same thing, they're both congruent to angle B, they must be congruent to each other. All right, now some more review. Angle addition postulate. This is something we have to be really good at, all right, for the whole year. Just not this test, just not whatever, the near future, but identifying angles by using 3 letters. All right, so this angle right here is, angle ABD. All right, remember, B is the vertex, so B must be the middle letter. Then we call this angle over here DBC. All right, using 3 letters, or I could say CBD, but B has to be in the middle because it's the vertex. Then it's equal to the whole thing. It's equal to the measure of angle ABC. All right, that's the angle addition postulate. All right, and just to review, what does this statement read, or this little notation? Measure of angle ABC. Measure, we just write M. Angle, we draw a little angle. So that's what that means. All right, so that's the angle addition postulate. We're allowed to add 2 smaller angles to equal the whole thing. And then linear pair postulate. I actually hate the linear pair postulate. If I could go back in time, if I owned a time machine, I would go back and rewrite the linear pair postulate. But I do not own a time machine, so I can't do it. It says, if 2 angles form a linear pair. So in this case right here, it'd be angle 1 and angle 2. If 2 angles form a linear pair, then, and now I bet some of you, if you want to complete the sentence by yourself, you're saying then they add 180 degrees. If it was up to me, that's what the linear pair postulate would say, that 2 angles form a linear pair, then they add to 180 degrees. Unfortunately, that's not the case. I don't know who was in charge of creating the linear pair postulate, but they did a pretty bad job. They wrote, if 2 angles form a linear pair, then they are supplementary. All right, and as we progress through two-column proofs, you'll see why I hate the linear pair postulate. I think it's a little too redundant. And then remember, just supplementary angles add up to 180 degrees. All right. So just a little preview of what we're going to see is we're going to have to write 1 and 2 are supplementary. 1 and 2 form a linear pair. So 1 and 2 are supplementary. So they add up to 180. All right, it gets a little lengthy, a little too lengthy, but it's what we got to do. We got to be very tedious. All right, now this is why I like angle proofs the best, because we actually start to prove theorems. And the first theorem we're going to prove is the vertical angles theorem. All right, the vertical angle congruence theorem, that is. Your whole life in math, your teacher tells you something, you accept it as fact. Why does this work? How do we know this is true? It's because the teacher says so. All right, what I really like about geometry is we're going to press pause. We have the vertical angle congruence theorem. Well, let's actually prove this theorem. We're going to prove this theorem to be true for any vertical angles that have existed in the past, that currently exist now, or that will exist in the future. All right, and if you can remember all the way back to the beginning of this unit, we proved statements to be false by just one counterexample, and to prove statements to be true, we have to prove to be true for all cases. And a lot of times, all cases means an infinite amount of cases. So there's an infinite way that vertical angles could look. It could look like this. What if they're skinnier? What if they're fatter? You could spend your whole life drawing different kinds of vertical angles. But we're going to prove that the vertical angles congruence theorem is true for all cases. So you have to be really clever and really smart. Anyways, let's dive in. All right, angle 1 and angle 2 form a linear pair. Angle 2 and angle 3 form a linear pair. So basically it's just saying we have some linear pairs. 1 and 2 is a linear pair. We can just tell by looking at the picture, but it's given. All right, now, like we just talked about, the linear pair postulate says that they're supplementary. All right, so 1 and 2 are supplementary and 2 and 3 are supplementary by what we had above, which was the linear pair postulate. To me, I wish we could just immediately say they add up to 180, but we can't. All right, and then, well, if 1 and 2 are supplementary, 2 and 3 are supplementary, that must mean the measure of angle 1 plus the measure of angle 2 equals 180 degrees. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. That's just by the definition of supplementary. And remember, when we do two-column proofs, a big thing to look for is buzzwords. All right. We didn't have very many buzzwords in segment proofs, basically just midpoint. But look at all these buzzwords we have here. We have linear pair, linear pair. So what are we going to use? The linear pair postulate. We had supplementary, supplementary. So what should we use? The definition of supplementary. So when we see these keywords, these buzzwords, chances are we're going to use the postulates, the definitions, and other things like that. What we also have, what we also can utilize is previous statements. Previous statements. All right, so how angle 1 and angle 2, they add up to 180. Angle 2 and angle 3 add up to 180. They equal the same thing, so they must equal each other by transitive. All right, so we use the previous statement to determine that one. Then, when we go from 4 to 5, notice how angle 2 just disappears. The measure of angle 2 is gone. Well, that's because I subtracted it from both sides. So that's a subtraction property of equality, but I'm going to be a little lazy and just write subtraction. And then, as we progress, as we get better with proofs with time, we'll start to notice patterns. You might be completely lost with proofs, but we have to know what we're trying to prove. It's always my last statement. All right? Think about a lawyer. Whatever they're trying to prove, that's what they're going to talk about in their closing arguments. So I'm going to say angle 1 is congruent to angle 3, and that's because I went from equals to congruence. That's by definition of congruence. So this is a very powerful moment. We just proved our first math theorem to be true. All right? There's an infinite amount of vertical angles that could exist, and we proved that all of them are congruent. Ooh, do you guys feel stronger now, mentally stronger? Do you guys feel the power of math flowing through your veins? This is a huge life skill, all right? This is a leap in thinking abilities, all right? We're going to keep practicing this, and we're going to get better at it. Stay tuned for the next videos.